So I'm going to talk about how to make and interpret a scatter plot. So here is a set of data. This is um, temperatures, the low daily temperature, and the number of coats sold. So this is about shopping in the winter. Is there a correlation between low temperatures and people buying coats? So we're going to plot these points and see what we see. So first thing I want to do is give this scatter plot a title, or else it's just a bunch of random dots that don't mean anything. So I'm going to call it shopping in winter, just like what we see there. Okay, there we go. And I'm going to label these axes. Now the x-axis is going to be low daily temperature. Let's see, low daily temp in Fahrenheit. And reposition that. And my y-axis is going to be number of coats sold. So number of coats sold. And let me flip that. That goes right here. Okay, so now I need to figure out a scale for both the x-axis and the y-axis. Now let me look at what's the biggest number on this on the x-axis. So let's see, is 19 the biggest? No, there's a bigger one. 26, there's 28. So 28 is probably the biggest number on the x-axis, and let's see what's the biggest number on the y-axis. 54. So I have here 1, 2, 3, 4, 5, 6. I noticed if I went by fives, I could go up to 30. So then 28 is a little bit less than 30. So that sounds like it would be okay. So 5, 10, 15, 20, 25, and 30. So that's my x-axis. I think that would work well. My y-axis is going up to 54, and I have 1, 2, 3, 4, 5, 6. If I went by tens, I could go up to 60, and that's just a little bit more than 54. So I'm going to go by tens. 10, 20, 30, 40, 50, and 60. Ooh, 60. So now I'm going to plot all of these points. Now we know this is, we're going to treat this like, we know this is on the x-axis, we labeled it so, and this is on the y-axis. So each one of these pairs is an ordered pair. So I'm going to just plot these. So 12, 38. 12 is, oops, 12 is a little bit after 10, not quite 15. So I'm going to start there, and then I'm going to go up to 38, which is a little bit less than 40. So there's my first point. And then I have 1931. So 19 is a little bit less than 20, and I'm going to go all the way a little bit past 30 for 31. And my next one is 854. So 8 is a little bit less than 10, and 54 is going to be about halfway between 50 and 60. So let's say it's there. 1735. 17 is between 15 and 20. I'm going to go up to 35, which is about halfway between 30 and 40. So I'm going to go there. 949. It's a little bit less than 10 to a little bit less than 50. So right there. And then 2616. So that's a little bit after 25 and somewhere between 10 and 20, maybe a little bit more than half. So probably right there. And then I have 1532. 15 is right here, and a little bit more than 30, maybe halfway between 30 and, well, no, 30, halfway, it would be about maybe a fourth of the way. So like right here. And 28 and 11. So 28 is a little bit more, it's a little bit under 30, and 11 is a little bit more than 10, so it's like right here. So I have, if you look at this, well, let's go to the next page, analyzing these scatter plots. So when you want to see the correlation between, or the relationship between two things, and you make a scatter plot and you see it going this way, that means that there is a possible correlation that as this thing gets bigger, this gets bigger. So, for example, like I told in my students in my class, the more cake I eat, the bigger my clothes get. Or there's this one, where the more cake I eat, the less cake I have in my house. And then there's this. There's no correlation. Let's say this x-axis is still the amount of cake I eat. This y-axis is my students' test scores. And if I were going to plot my students' test scores based on how much cake I ate, I would find that there is no correlation. There's no relationship between these x and y values. My students will not do better or worse. They will not change at all based on how much cake I eat. Now, if we go back to this, we can see there is a correlation here. As the daily temperature gets warmer, people buy fewer coats, and that makes sense. So we're just going to analyze one last scatter plot. This scatter plot shows a relationship between the number of hours of baseball players practiced and the number of hits they got. So we'll use this to answer the questions. How many hours did the player who got 6 hits practice? Well, so now they're asking us about something from the y-axis. Usually we get asked about stuff from the x-axis, but we're going backwards in this problem. So 6 hits is right here, and there's one player that got 6 hits, so let's go down to the y-axis and see how many hours he put in practicing. And it's between 20 and 30, so it's 25. And the player who got 6 hits practiced for 25 hours. How many hits did the baseball players who practiced more than 30 hours get altogether? Okay, so if we look at the players that practice for more than 30 hours, I'm not going to include this guy because it's exactly 30 hours. So it's just these two. Okay, so I need to figure out, well, how many hits did they get total? So this guy is between 6 and 8, so it's probably 7. He got 7 hits, and this one's between 4 and 6, so he got 5 hits. So if I add 7 hits plus 5 hits, that is 12 hits. And by the way, it looks like there's a positive correlation here between practice and getting more hits. As you might expect, when you practice more, you're more successful. Anyway, back to the questions. As the number of hours of baseball practice increases, does the number of hits increase, decrease, or stay about the same? So, well, I guess we're talking about the same thing. So as I'm looking at this, I can see that this person who practices for 10 hours gets 1 or 2 hits. These people who practice for 40 hours get 5 or 7 hits. So there's definitely an increasing trend here. So the number of hits increases. And that is Scatterplots.